I want you to picture a scenario. It's a Tuesday morning. You're walking into one of those big Class A office buildings downtown,
Okay.
or maybe you're checking into a new hotel for a conference. You go through those big glass revolving doors, that rush of, conditioned air hits you, and you head for the reception desk. And right there, mounted on the
I
wall,
know exactly what you're talking about.
yeah, it's usually on the right eye level, polished to a perfect shine, is a plaque.
I can picture it immediately. It's usually that brushed silver look, or sometimes it's a thick piece of glass with those fancy metal standoff bolts.
Exactly, and it has that little seal on it, the leaves, the globe thing, and it says all LEED certification.
Hmm.
Maybe it's a silver, maybe gold, or if the developer really, spent some serious cash, platinum.
Hmm.
We see these things absolutely everywhere now, and I think for the average person, and I'll include myself here, you look at that plaque, you give a little internal nod, and you think, okay, good, this building is one of the good guys. It's saving the planet. It's a green building. And then you get in the elevator and, check your email.
That is precisely the intended effect. It is the modern seal of approval for the built environment. It's a signal that says, we care.
Right. But today I want to sort of stop the elevator. I want to stand in that lobby and really stare at that plaque for a minute, because I started wondering, what does it actually mean?
Mm.
Is it this rigorous scientific proof that this building is an environmental superhero? Or is it basically a participation trophy for a developer who just, filled out the right paperwork and paid the right fees?
That is the multi-billion-dollar question. And frankly, the answer is going to frustrate you, it's going to fascinate you, and it will probably make you look at every single building you enter a little differently from now on.
That's what we're here for. So welcome to the deep dive. Today we are taking a sledgehammer, metaphorically of course, to the LEED certification system.
Metaphorically.
LEED, which stands for Leadership in Energy and Environmental Design. We are going to unpack the history, the weirdly addictive point system, this phenomenon called lead brain, and the actual hard data on whether these buildings save energy or, just burn cash.
It's a massive topic. And to be clear, right off the bat, we aren't just talking about a little plaque. We're talking about, well, probably the single most dominant force in global construction over the last 25 years.
Let's just establish the scale here for a second, because I think there's this misconception that this is just a coastal elite thing, something you only find in San Francisco and Brooklyn, but nowhere else.
Oh, that couldn't be further from the truth. If you look at the numbers, as of 2024, LEED is omnipresent. We're looking at over 195,000 ED-certified buildings worldwide.
195,000.
And that's spread across 186 countries. So while it started here in the U.S., it is now, for all intents and purposes, the global lingua franca of sustainable building. If you go to mainland China, India, Canada, Brazil, Sweden, you are seeing these plaques absolutely everywhere.
So why those countries specifically? Is it just that they're building a lot of new stuff?
That's a huge part of it. China and India are going through this massive urbanization. They need a framework to ensure they aren't just building, energy-sucking monsters.
So it's a shortcut.
It's a shortcut to having a standard. It also signals to international investors that this particular asset is Class A quality. It's a global mark of prestige.
So it's as much a financial signal as it is an environmental one.
Oh, absolutely. Maybe more so.
What about back home in the U.S.? Who's winning the green race here?
If you look at it by square footage certified per person, which is really the best way to normalize for population size.
Right, to make it fair.
Yeah, to make it fair. The District of Columbia just destroys everyone else. D.C. is the capital of green building. But among the states, you've got the usual suspects: Massachusetts, Illinois, New York, California.
And it's not just skyscrapers, right? We're not just talking about office towers.
No, and that's the really interesting part of its reach. It's hospitals, it's elementary schools, it's those massive Amazon distribution centers you see everywhere.
Oh, interesting.
And even private homes. Although, to be fair, the residential side of it is a much smaller piece of the pie. The real sweet spot for LEED is big commercial infrastructure.
Okay, so it's everywhere. It's the global standard, but it had to start somewhere. I'm assuming this was some kind of government mandate. Did the EPA cook this up in a basement in the 90s to force developers to behave?
You would think so, wouldn't you?
Yeah.
But no, and this is absolutely critical to understanding why the system works the way it does. LEED is, and always has been, a voluntary market-driven system.
Voluntary?
Completely. It wasn't the government, it was the private sector.
So developers essentially asked to be regulated. That sounds a little uncharacteristic for the real estate industry.
Well, you have to go back to the vibe of the early 1990s. specifically April 1993.
Okay, paint the scene for me. Nirvana is on the radio, everyone's wearing flannel, and construction is what?
Construction is the Wild West of greenwashing. The term green building was just starting to float around, but nobody, and I mean nobody, knew what it meant.
It was just a buzzword.
A total buzzword. A developer could slap a recycling bin in the lobby and say, hey, we're a green building. Another developer could install a couple of solar panels. A third one could just plant some nice oak trees out front.
And they all claim to be green.
Exactly. But if everything is green, then nothing is green. It was marketing chaos.
Okay, so a problem in search of a solution.
Precisely. So the U.S. Green Building Council, or USGBC, was formed to fix this. And the founding trio, it really sounds like this setup to a bar joke.
I'm listening.
You had Rick Vidridzi, who was a marketing guy at Carrier, the air conditioning giant.
Okay, a marketing guy.
You had David Gottfried, a real estate developer, and Michael Italiano, an environmental lawyer.
Marketing, real estate, and law. That is not the Captain Planet squad I was expecting. Where are all the, the tree huggers?
Oh, they were there. But this leadership group is very telling. They understood from day one that for this to work, it couldn't just be about saving the polar bears. It had to make business sense.
It had to work for the market.
It had to. They first met at the American Institute of Architects boardroom. It started with about 60 firms.
And they needed a rule book, a common language.
They needed a yardstick. And for that, we have to introduce the George Washington of this whole movement, a man named Robert K. Watson.
The founding father of LEED.
Yes, that's what he's called. He was a senior scientist at the Natural Resources Defense Council, the NRDC. He's the one who actually coined the acronym LEED. And more importantly, he shepherded this thing through what was called the consensus process.
Consensus process sounds like a very polite way of saying herding cats.
Oh, it was brutal. Could you imagine getting carpet manufacturers, steel tycoons, architects, and hardcore environmentalists all in the same room? And trying to get them to agree on how many points a bamboo floor is worth? It took years. But Watson held it all together because he knew, fundamentally, the market needed a standard. Without a standard, you couldn't prove value.
So they built the machine. Let's talk about how this machine actually works. Because when I look at that plaque, I really do feel like I'm looking at a high score on a video game.
That is the perfect analogy. LEED is the gamification of construction. It turns building a skyscraper into a role-playing game where you're just grinding for experience points.
Okay, so break down the scoreboard for me. How do I win this game?
The structure is actually pretty simple. You have a scorecard with 100 base points available, plus a few extra bonus points you can get for innovation or something called regional priority.
Right.
And depending on how many of those points you manage to collect, you unlock a different achievement level.
These are the tiers,
Yeah.
the silver, gold, platinum.
Right. So if you just get 40 to 49 points, you are certified. That's the entry level. It basically means you did a little bit better than the bare minimum legal code.
That's the participation trophy.
Pretty much. Then 50 to 59 points gets you silver, 60 to 79 gets you gold, and then the big one, the status symbol that every CEO wants for their global headquarters, is platinum. That requires 80 points or more.
So getting a platinum building is basically like getting an A- or maybe a B+ on your report card. 80 out of 100.
In a school setting, maybe?
Yeah.
But in the world of construction, getting 80 points is incredibly difficult. It requires a really concerted effort across every single category of the design.
Then what are those categories? I'm assuming energy is the big one.
Energy and atmosphere, or EA, is the heavyweight champion for sure. It has the most points available.
Okay.
But you also have sustainable sites, which is about where you build and how you treat the land. Water efficiency, low-flow toilets, drought-tolerant landscaping.
The usual stuff.
The usual stuff. Then you have materials and resources. Are you using recycled steel? Is your wood certified as sustainably harvested? And then a really important one, indoor environmental quality airflow, low toxin paints, access to daylight.
Now, I have to ask the cynical question here. Does this cost money? And I don't just mean the cost of buying better windows. I mean, does the plaque itself cost money?
Oh, absolutely.
Huh.
You have to pay the game. You pay registration fees and certification fees to an organization called the GBCI, the Green Building Certification Institute.
And how much are we talking?
For a massive, complex campus project, these fees alone can run upwards of $1 million.
Wait, hold on. $1 million just for the bureaucratic privilege of getting the plaque, not for the actual materials in the building.
For the very largest projects, yes, the administrative fees can get that high. For a normal office building, it's more like tens of thousands. But the real cost isn't even the fee. It's what they call the soft costs.
Soft costs. That sounds like a euphemism for lawyers.
Consultants, energy modelers, commissioning agents. To get a LEED certification, you almost always have to hire a specific LEED consultant.
And their whole job is just to manage the paperwork.
Their entire job is to track the paperwork, manage the point scorecard, and argue with the USGBC reviewers over every little detail. Studies show all this administrative and design overhead adds about 1% to 6% to the total project budget.
So if I'm building a $500 million tower, I might be lighting, what, $10, $20 million on fire just to manage the paperwork for this plaque?
You might be, but the developer would argue they aren't lighting it on fire. They would say they're investing it in an asset that will command higher rents and attract better tenants.
Okay, so there is a financial logic there. But here is where I want to pivot to the real controversy. Because you dropped a bomb on me when we were prepping for this. You said something that I'm still trying to wrap my head around. You said LED is a design tool, not a performance tool.
Yes. And if you take nothing else away from this whole deep dive, please take this. Historically, that plaque on the wall is an award for intent, not necessarily for results.
Okay, explain that. Because if I buy a car that says it gets 50 miles per gallon on the sticker, and I drive it off the lot and it only gets 12, I can sue somebody for false advertising.
Buildings are different. When you submit for LED certification, the building usually hasn't even been occupied yet. It's an empty shell. So how can you prove it's energy efficient? You can't show them a utility bill.
Right, there is no utility bill yet.
So you show them a computer model.
A simulation.
Exactly. You hire a team of engineers to build a digital twin of your building in a computer. They input all the specs, the R value, the insulation, the efficiency of the chiller, the power density of the lighting.
Okay.
And then, and this is the absolute key, they compare that model of your building to something called a baseline building.
What on earth is a baseline building?
It's a hypothetical, totally imaginary building. It's the same size and shape as yours, but it's designed to be built to the bare minimum legal code. It is essentially the mediocre ghost of your building.
So the test isn't, are you efficient? The test is, are you better than a piece of junk?
In a nutshell, yes. If your computer model shows that your design will theoretically use 20% less energy than the mediocre ghost baseline, you get the points.
But models are. They're squishy. I mean, you can make a model say a lot of things depending on the assumptions you plug in.
And welcome to the wonderful world of modeling gymnastics. Engineers are very, very good at tweaking the assumptions to improve the score. For example, the model might assume that the automated daylight sensors will perfectly dim the lights every time the sun comes out.
But in reality,
maybe that sensor's a little finicky, so the facility manager just puts a piece of duct tape over it to keep the lights on 100% of the time.
So the model says savings.
But reality says waste. The LEED reviewer, however, only ever saw the model. You get the plaque based on the simulation, not the reality.
That feels like a massive, massive loophole. If nobody ever comes back to actually check the meter, you can just game the system from the start.
And that leads us directly to the concept of LEED's brain.
LEED brain. I love this term. It sounds like some kind of disease.
It kind of is, in a way. It was coined in a really scathing 2005 article by two guys, Auden Schindler and Randy Udall, titled, "LED is broken, let's fix it."
Okay.
And they argued that the point system causes people to lose their minds. The goal stops being, let's build a good, efficient building, and it becomes, let's get the points.
Just point mongering.
Pure point mongering. It's the classic teaching to the test problem. Imagine you're a designer. You have limited budget. You could spend, say, $50,000 on a really sophisticated, high-efficiency HVAC upgrade.
That sounds like it would save a ton of carbon.
A ton. But it's hard, it's expensive, and it might only net you, say, 2 points.
Right.
Or you could spend that same $50,000 installing some bike racks, a shower for commuters, using some recycled carpet, and putting in a native plant garden.
And those are cheap and easy.
They're cheap, they're easy, and they might get you 5 points.
So you buy the bike racks, you skip the hard HVAC upgrade, and you end up with a gold rating instead of a silver. But the building is actually worse for the planet.
Precisely. You prioritize the cheap points over the hard points. Schindler and Udall pointed out all these absurdities, like the reflective roof debate.
Oh, this is the one about the Rocky Mountains, right?
Yes. So a white reflective roof is great in Miami or Phoenix. It bounces the sun's heat back into space and keeps the building cool. LE gives you a point for that to reduce the heat island effect.
That makes perfect sense.
But LE, at least in its earlier versions, gave you that point regardless of where your building was located. So you had designers in the high Rocky Mountains in ski towns seriously debating putting white roofs on their buildings.
Wait a minute. If you're in a ski town, you want a black roof. You want to absorb every bit of heat you can get to keep the building warm.
Correct. A white roof in a heating-dominated climate actually increases your heating bill. It is environmentally stupid. But if you're 2 points away from that coveted platinum plaque, and the white roof is an easy point to get,
LE brain takes over.
it takes over. You do the objectively bad thing to get the good badge.
That is just maddening. It's putting bureaucratic compliance completely over common sense engineering.
It is. But if you think that's bad, we really need to talk about the location paradox. Because this is where the wheels, in my opinion, really fall off the wagon.
This is the argument that a so-called green building in the wrong place isn't green at all.
That's the one. This has been championed by critics like David Owen, who wrote Green Metropolis, and Jeff Speck, the urban planner. And their argument is elegantly simple. The transportation energy associated with a building often completely dwarfs the energy the building itself uses.
It's the commute.
It's always the commute. If you build a platinum-certified net zero fortress of sustainability, but you build it in the middle of a cornfield 20 miles from where anyone actually lives, you've failed.
Because everyone has to drive their SUV to get to your eco-fortress.
Exactly. Let's look at the famous Gap Inc. example. Gap built this stunning green building in San Bruno, California. It had a grass roof. It had amazing natural light. It was celebrated everywhere.
Sounds great.
But it was located 16 miles from their headquarters in downtown San Francisco.
So what happened?
Well, people couldn't walk there. They couldn't easily take public transit. So Gap had to run its own fleet of private shuttle buses back and forth all day. And David Owen dropped this just hammer of a quote, "No bus is as green as an elevator."
Wow. That hits hard. No bus is as green as an elevator.
Think about the physics of that. If Gap had just leased more space in an old, supposedly inefficient skyscraper right there in San Francisco, their employees would have just taken the elevator or walked or taken the BART.
Right.
By moving to the green campus, the carbon emissions from the shuttle buses and all the employee cars completely wiped out any savings from the building's fancy efficiency features.
So it's a net loss for the planet, but it's wrapped in a pretty green bow.
And there's an even worse example, the EPA itself.
Oh no. Please don't say the Environmental Protection Agency.
The EPA Region 7 headquarters. For years, they were located downtown in Kansas City, Missouri. Then they moved to a suburb called Lenexa, Kansas, which is about 20 miles away.
And they moved into a shiny new LED building.
A shiny new LEED gold certified building.
Let me guess. The commute emissions killed them.
It was a massacre. Cade Benfield from the NRDC actually ran the numbers. He looked at the total carbon footprint per employee, including their commute. By moving from the dense city center to the sprawling suburb, the carbon emissions per person almost tripled.
Tripled? That's not a rounding error.
It went from 0.39 metric tons per month to 1.08. The building itself was efficient. It had great insulation, great windows. But the simple physics of hundreds of people driving 40 miles round trip every single day completely overwhelmed the physics of the building.
Wow.
Jeff Speck put it brutally. The carbon saved by the new building's LED status will be a small fraction of the carbon wasted by its location.
That is just devastating. It really suggests that where you build matters maybe 10 times more than how you build.
And for a very long time, LED did not weight that heavily enough. You could get a platinum certification for a building in a totally parking-dependent suburb. And that, I think, is a fundamental flaw in the philosophy.
Okay, so the location can ruin it, the gaming of points can ruin it, but let's zoom back in on the building itself again. Let's assume, for the sake of this argument, we have a LE building in a good, walkable location.
Okay.
Does the plaque on the wall actually prove that it's saving energy? We talked about the models, but what about the actual real-world data?
Now we enter the data wars. And this is where things get really nerdy and really, really contentious.
I'm ready. Take me to the data.
Okay, the seminal moment was in 2009. The USGBC released a big data set, and then a team led by a scientist named Guy Newsham at the National Research Council of Canada analyzed it. They looked at 100 LEED buildings to see if they were actually saving energy compared to conventional buildings.
The moment of truth. And the verdict was?
The headline was positive. On average, the LE buildings consumed 18% to 39% less energy. The USGBC took a big victory lap.
On average, I can feel a butt coming, a really big butt.
It's a huge but. Because Newsham found that while the average was good, the scatter plot of the data was terrifying. Roughly 28% to 35% of the LEED buildings in the study actually used more energy than their conventional counterparts.
Wait, say that again? 1/3 of the green buildings were actually brown buildings.
That's what the data showed, yes. If you walked into a random LED building back in 2009, there was about a 1 in 3 chance it was performing worse than a standard code-compliant box.
That's shocking.
And it gets worse. Newsham found absolutely no correlation between the number of energy points a building earned in its LED scorecard and its actual measured performance.
So getting a gold or platinum for your energy design didn't actually mean you saved more energy in the real world.
Zero correlation. The points, as a predictor of performance, were meaningless. But then a physicist named John Schofield entered the chat, and he basically flipped the whole table over.
I love when a physicist shows up to an architecture party. They always ruin everything with math.
Schofield looked at the very same data, but he said, "You guys are all measuring the wrong thing." He argued that LEED was obsessed with site energy, but the planet only cares about source energy.
Okay, we need to stop and unpack this. This sounds technical, but it also sounds like it might be the whole ballgame. Site versus source. Explain it like I'm 5.
Okay, site energy is simple. It's what your electric meter on the side of the building reads. If your building uses 10,000 kilowatt hours in a month, that's your site energy.
That seems fair. That's what I pay the utility company for.
It is. But where did that electricity come from? That is source energy. Let's say you have a building in Seattle. It's mostly powered by clean, efficient hydroelectric dams. Now, take that exact same building and magically move it to West Virginia, where the grid is powered mostly by burning coal.
Same building, same lights, same meter reading.
Same site energy. But in West Virginia, to get that 10,000 kilowatt hours to your meter, the power plant had to burn a massive amount of coal. And a huge amount of that energy was lost as waste heat during generation, and then more was lost during transmission over the power lines. The source energy, the raw fuel burned at the power plant, is maybe 3 times higher in West Virginia than it is in Seattle to deliver the same amount of power to the building.
So the environment cares about the coal burned at the source, but the building owner only sees the meter reading at the site.
Exactly. And Schofield found that LEED was awarding all its points based on site efficiency. This led to some real perversities. For example, electric heating is very efficient at the site. But if that electricity comes from a coal plant, it is absolutely terrible at the source.
So he reran the numbers.
You recrunched the numbers using source energy, and he found nothing.
Nothing.
No statistically significant reduction in source energy or the associated greenhouse gas emissions for LE buildings compared to conventional ones. From his perspective, the plaque meant absolutely nothing for the climate.
That is a bombshell. The physicist basically says the emperor has no clothes.
It was a massive, massive controversy. And subsequent studies have kind of confirmed pieces of this. A 2013 study of office buildings in New York City showed that while the gold-rated buildings were okay, the silver and certified buildings actually used 11% to 15% more source energy than conventional buildings.
So the lower-tier LA buildings were actively part of the problem. Why? I mean, how is the modeling failing this badly?
Well, aside from the whole site versus source issue, I think the biggest culprit is us, the humans inside the building. The technical term is plug loads.
The stuff we plug in.
All stuff we plug in. Models are great at predicting the things that are fixed, like lights and pumps and fans. They're terrible at predicting what you and I are going to do.
Right.
We bring in mini fridges for our lunch. We plug in space heaters under our desks because the AC is always too cold. We set up entire server racks and closets that were never designed to handle that heat load.
The secret space heater under the desk. The silent killer of sustainability.
It's the enemy. A study by Fortes and Chavon showed that these plug loads are like the dark matter of building energy use. The model assumes a standard office worker who behaves perfectly. But real people are mussy. They leave windows open while the heat is on. They work 18 hours a day instead of 8. The building is designed like a Ferrari, but it's being driven by a teenager who leaves the parking brake on.
Okay, so on energy, the verdict is shaky. Shaky at best. But we don't just measure buildings by their carbon footprint, we also measure them by how it feels to be inside them. Is there a bright side to this story?
There is a very bright side. While the energy data is a complete war zone of conflicting studies, the data on indoor environmental quality, or IEQ, is much, much clearer. LE buildings are objectively healthier for humans.
This is the air quality stuff you mentioned.
Right. LED has very strict credits for ventilation rates, for using low-emitting materials like paints and glues and carpets that don't off-gas toxic chemicals, and for high-quality air filtration.
And does that actually matter? Or is it just that it, smells nicer?
Oh, it matters for your brain. There was a famous study at Harvard by Joseph Allen called the CogFix study, and it looked at cognitive function. They put people in controlled environments and found that in high-performing green building conditions with low CO2 and low VOCs, cognitive scores were significantly higher.
So you're literally smarter in a LEED building.
You're less dumb, essentially. High CO2 levels from poor ventilation make you sluggish and sleepy. Sick building syndrome is a real thing. Headaches, fatigue, dry eyes. And the data clearly shows that occupants in LEED buildings report far fewer of these symptoms.
Now that is a real return on investment. If your employees are even 5% more productive because the air is clean, that pays for the entire building pretty fast.
Exactly. People forget that the salary cost to the people inside the building is about 100 times higher than the energy cost of running the building. So even if the energy savings are a complete wash, the human health and productivity benefits alone might justify the certification.
But are people happier? What do the satisfaction surveys say?
Mostly, yes. Although there is a funny little detail on the data. People in LE buildings are often slightly less satisfied with the acoustics and the lighting.
The lighting? Why the lighting? I thought they were all about daylight.
They are, but energy efficiency often means automated controls. You know those motion sensors that turn the lights off and you sit too still for 5 minutes?
Oh, I hate those sensors. I'm always waving my arms around in the dark like an idiot trying to get the lights back on.
Exactly. Or the automated blinds that close on their own when the sun gets too bright. People hate giving up control. They hate the nanny building turning off their lights for them. And that frustration shows up in the satisfaction surveys.
Interesting.
And actually, there's a new rival in town on this front called the WELL Building Standard.
Well.
Yes. It's a certification that focuses only on human health and wellness. And a 2024 study compared them and found that occupant satisfaction in WELL-certified buildings was around 94% compared to only 73% in LEED buildings.
So a big gap.
A big gap. The LEED is good for health, but because it has to split its focus between energy and materials and water and health, it's not the ultimate wellness experience.
Okay, so we've dragged Ellie through the mud a little bit here. We've bashed the energy data. We've mocked the bike racks. But we have to acknowledge that the USGBC isn't deaf. They hear these criticisms. The system has evolved over time.
That's only fair to say. I mean, we aren't using Windows 95 anymore, and we aren't using LEED version 1.0. It's gone through multiple iterations, and we are now moving into the era of LEED V5.
What's the big headline for V5? Is it just more points for bike racks?
No. The headline is one word: decarbonization. The USGBC has finally realized that energy cost savings is a bad and misleading metric. They are pivoting hard to carbon.
So they're finally trying to fix that whole source energy problem.
Yes. The new drafts are being written to align with the goals of the Paris Agreement. They are putting a huge emphasis on operational carbon, which means looking at the actual utility bills, looking at the grid mix of the local utility. They are finally moving from rewarding design intent to rewarding verified performance.
So the participation trophy is finally becoming a performance review.
That's the hope. They're also adding new categories for resilience. Can the building survive a flood or a heat wave? And equity. Does the building actually help the surrounding community? It's a much more mature, much more holistic system than that simple checklist from 2005.
I want to wrap up here by looking at some specific examples. We talked about the bad ones, the Gap building, the EPA disaster. Let's talk about some of the icons, the buildings that really got it right.
We have to start with the Empire State Building.
The King Kong building, an icon of the 1930s.
Exactly. Around 2010, the ownership decided to do a massive energy retrofit. Now, usually when people think green building, they think of some new shiny glass spaceship. But the greenest building is the one that's already built.
Right, because all the carbon to make the bricks and the steel was already spent 80 years ago.
The embodied carbon is sunk. But the Empire State Building was an absolute energy hog. It had 6,500 original single-pane, incredibly drafty windows.
So what do you do? I mean, you can't just go to Home Depot and buy 6,500 windows for a historic landmark.
No, and you can't just throw them all in a landfill either. So they did something just incredible. They built a window factory on the 5th floor of the building.
They built a factory inside the skyscraper.
A mini factory. They would remove the windows a few at a time, bring them up to the 5th floor, strip them down, reuse the original glass panes and frames, add a super insulating film between the panes, fill the cavity with gas, and then reinstall them. They reused 96% of the original materials.
That is insanely cool. Just brilliant problem solving.
It is. It cut the energy use of the building by close to 40%. The project achieved LEED Gold, and it proved that you don't always need high-tech gadgets. You just need really smart, common-sense engineering.
What about new construction? What's the gold standard, or I guess the platinum standard of what's possible?
For me, I love the Crystal in London. It's a building dedicated entirely to the topic of sustainable cities, and it achieved both LEED Platinum and BREEAM. Outstanding BREEAM is the very strict British rival system.
So it won the double crown.
It's a living machine. It generates its own energy with solar panels and ground source heat pumps. It collects and recycles rainwater. It's fully automated. It is what all those computer models promise, but actually brought to life in reality.
And just for the sports fans out there, I saw that stadiums are getting in on this too.
It's a huge trend. Levi Stadium, where the 49ers play, was the first NFL stadium to get LEED Gold. And then U.S. Bank Stadium in Minneapolis, home of the Vikings, got platinum.
Wow, platinum.
And that's incredibly impressive because stadiums are energy nightmares. You have the massive floodlights, the giant scoreboards, and thousands of toilets all flushing at halftime.
If a stadium can be green, anything can be green.
That is absolutely the message.
So we've arrived at the end of our deep dive. We've seen the plaque, we've analyzed the data, we've exposed the loopholes. What is the final verdict? When the listener walks into that lobby tomorrow and sees that silver plaque on the wall, what should they think?
They should think with nuance. EVI is not a magic wand. A plaque does not guarantee that the building is saving the planet, especially if that building is sitting in a car-dependent suburb or if all the tenants are plugging in space heaters under their desks.
It's not a guarantee of perfection.
Not at all. But, and this is a really big but, it has been a transformative force. You cannot deny the levee changed the entire conversation in the construction industry.
Okay.
It forced a very slow, very conservative industry to learn a whole new language. It made sustainability a boardroom topic. It pushed entire supply chains to make non-toxic paints and recycled carpets standard, not specialty items.
So it raised the floor for everyone, even if the ceiling is still a little bit messy.
That's a perfect way to put it. It made the average building built today much better than the average building from 20 years ago. And financially, the data is crystal clear. LE buildings command higher rents and have higher occupancy rates. The market values the plaque, even if the physics are still debatable.
So the plaque means we tried, and maybe more importantly, we did better than the other guy would have.
It means intention.
And here's the thought I want to leave you with. As we look at LED V5, and as we stare down the barrel of the climate crisis, maybe we don't have time for intention anymore. Maybe we only have time for results.
We need proven performance.
Should we stop awarding points for effort? And maybe more pointedly, should a building ever get a platinum plaque if it requires every single person to drive an SUV to get there? Maybe the definition of a green building shouldn't just be about the building anymore. Maybe it should be about the life it forces all of us to live.
That is the uncomfortable question that the next generation of architects and planners has to answer.
Something to chew on the next time you're standing there waiting for that elevator. Thanks for diving deep with us.
It's always a pleasure.